Welcome to Lesson 5-1, Understanding Ratios. Ratios are really the meat of 6th grade math, so we're really getting into it now. Thankfully, ratios shouldn't be a foreign concept to you. You've done it for a very long time. When you worked with fractions, you worked with a type of ratio, in that case a part-to-whole ratio. So let's get into it. We can use ratios to compare two different things. In this case, we're comparing the number of dogs to the number of cats here. And so they want us, and the order is important here. We got to pay attention to the order. In my sentence, it says use a ratio to compare the number of cats to the number of dogs. We got to keep it in that order, cats to dogs, cats to dogs. Now, we can write this in three different ways. We can use the word to. We could say that cats to dogs, and my ratio would be 14 to 17. That is the ratio, 14 to 17. Again, keeping my ratio cats to dogs, I could use a symbol, the colon, to represent the word to. So I could do a 14 colon 17. That's 14 to 17. You read it the same way as with the word to, 14 to 17. We also can write it as a fraction of cats to dogs. In this case, the first thing goes on top and the second thing goes on the bottom. So we get cats to dogs, which is 14 to 17. That's a part-to-part ratio. So there you go, 14 to 17. We can write 14 to 17 three different ways. 14 to 17 with the word to, with a colon, and as a fraction. All right, for this next part, we're going to do a part-to-whole ratio. Now they're asking me to compare the number of cats to the total number of pets. Well, they didn't give me the total number of pets, but I could figure that out. That's just going to be 14 plus 17. And so if I want to do cats to total, I could write that as 14 to 31. I could write it as 14 to 31. I could write it as 14 to 31. Three different ways, but you only need one of them. But those are the three possibilities. This next thing below is just the same as the one above. So we're going to change that. We're going to compare the number of dogs to the total number of pets. So make that change on your notes. I'd like you to write that three different ways on your own. What is the ratio of dogs to total number of pets? Go ahead and give it a try. Okay, now we're going to use ratios in a bar model to solve a problem. It says the ratio of footballs to soccer balls is 5 to 3. And so I have that ratio kind of set up with this bar model. I have 5 boxes here and 3 boxes there. They also tell me that they have 100 footballs. Of course, the Europeans would say, what do you mean soccer balls? Those are footballs. But anyway, that's another story. So anyway, I know that the total number of footballs is 100, and that's broken into 5 equal parts. And so 100 divided by 5, that means each part needs to be 20. Okay, these are all equal parts. And with the ratio, it's 5 parts to 3 parts. So these parts also have to be 20. And so you can see from the picture that they must have 60 soccer balls. 60 soccer balls, which to an Italian would be footballs. But anyway, we'll keep it American. We can also use a double number line to figure out ratio problems. So here I have a problem where Chen can ride his bike 3 miles in 15 minutes. Okay, so you can see on my number line I've lined up 3 miles, 15 minutes. Another 3 miles, another 15 minutes. And it keeps going like this. And they want to know how far he can go in 18 miles. Well, if I look at this, he can go 90. It takes him 90 minutes to go 18 miles. So for this next problem, we're also going to use a double number line. We're not going to do the bar diagram. We're going to use a double number line. Use a double number line to find out how long at least it would take to go 10 miles if she rides at this rate of 2 miles every 7 minutes. So you're going to also set up your double number line, right? And you know that, and if this is miles, and this is minutes, you know if she goes 2 miles in 7 minutes, right? And so that would be 4 miles in 14 minutes. We're going to keep doing this. We can figure out how many minutes it takes her to go 10 miles. Go ahead and figure that out. We'll talk about it in class. All right, we got some straight up practice here. Sixth grade basketball team has 3 centers, 5 forwards, and 6 guards. And we want to write ratios 3 different ways. We want to do forwards to guards and centers to total players. And then below we have a bar model problem. We have a ratio of blue to green cards of 2 to 5. And so we set that bar up. It says if there's 8 blue cards, how many green would there be? Give it a try. We'll go over it and have a good day.